This is Algebra 2, Lesson 77. It's problems similar to what we've worked in where we have a radical, but this time we're going to have a more complex radical, or we're going to have more than one radical. So historically, we would isolate a radical, right, on one side of the equal sign, everything else on the other side. We squared both sides, and then we solved, right? And always had to check these solutions. Always checking these solutions, all right? Now they're going to be more complex, all right? They're going to have a quadratic under the radical, or we're going to have two radicals. All right, so look at example 1 on page 321. It's the cube root. The cube root of x cubed plus 6x squared minus 4, that's what's under the radical, minus x minus 2 equals 0. Okay, you want to isolate the radical. So I'll add 2 and I'll add x on both sides so that we end up with the cube root of x cubed plus 6x squared minus 4 equals positive x plus 2. All right, when I have a square root, I have to square it. When I have a cube root, I have to cube both sides, because the cube root cubed is just what's under the radical. So I'm cubing both sides, okay? Everything has to be cubed. All right, so on the left-hand side, I'm just left with what's under the cube root. On this side, it's x plus 2 times x plus 2 times x plus 2. So I do have to multiply that out 3 times, all right? And I will begin by multiplying the first 2. So I'll ignore the last one. I'm just going to multiply these 2, and then I'll come back and multiply by this one. All right, the first one's x times x, x squared. Remember, the middle term is our outers plus our inners. So that's 2x plus 2 more x is 4x. Our last 2 times 2 is 4. Now I'm going to distribute x to each term, and then I'll distribute the 2. All right, x times x squared is x cubed. X times 4x, 4x squared. X times 4, 4x. Now I'm going to multiply 2 by every term. When I multiply this next time, I'm going to write under like terms so it's easier to add. 2 times x squared is positive 2x squared. 2 times 4x, 8x, and 2 times 4 is 8. So that I'm left with x cubed plus 6x squared minus 4, just double checking, yeah, equals x cubed plus 6x squared plus 12x plus 8. When you have the exact same term on both sides of the equal sign, they eliminate. Because I could subtract x cubed, on both sides they eliminate. I can subtract 6x squared on both sides, and they both eliminate. So I'm left with 12x plus 8 on the right hand side and negative 4. So I'm going to move the 8 through subtraction to the left. This is the only terms that I'm left with. 12x is negative 12. When I divide by 12, the value of x is negative 1. You have to check your answers. You have to check your answers, the solution. All right, so I'll go back in and plug -1. It's the cube root of -1 cubed plus 6 times -1 squared minus 4 minus -1 minus 2 equals 0. Okay, let's look what's under that cube root. That is the cube root. -1 cubed is -1. I was trying to move my camera up a little bit so you could see everything. Okay, that's -1. -1 squared is positive, so this is still going to be positive 6 minus 4. So that's going to be 6 minus 5, which is 1. Positive 1. So the cube root of positive 1 is just 1. 1 minus a negative plus 1 minus 2 equals 0. It does. It works. It is a solution. All right. Now in the next one, we're going to have 2 radicals. So you have multiple radicals. Look at example 2 on the bottom of page 321. We have the square root of k minus 5 minus the square root of k plus 1 equals 0. So I'm going to isolate one of the radicals, the largest one. So I'm going to isolate this one, move both of these to the other side. So I'm going to add square root of k, I'll subtract 1. And I'll leave square root of k minus 5 on the left-hand side. I'm going to square both sides. The entire term on both sides, I'm squaring. Knowing that when I square binomials, the binomial times itself. On the left-hand side, it's just k minus 5. On the right-hand side, it's the square root of k minus 1 times the square root of k minus 1. All right, then I'm going to FOIL the right-hand side. All right, square root of k times the square root of k. The square root of anything times the square root of itself is just what's under the radical. It's k. Square root of k times -1 is negative square root of k. -1 square root of k, negative square root of k. -1, -1, positive 1. Now, I'm going to move k to the other side. I'll move 1 to the other side and combine my like radicals. So I'll subtract k. I'll subtract 1. And we're left with -6 equals -2 square root of k. There's 2 of them, okay? I want to, again, isolate this radical. So I'll divide both sides by -2. So 3 is a square root of k. Now I square both sides. The value of k is 9. And I have to check them. Have to check it. Always. You have to check these. All right, so I'm going to put 9 in for k. So we're left the square root of 9 minus 5 minus the square root of 9 plus 1. Does that equal 0? That's 4. The square root of 4 is 2. Minus the square root of 9 is 3. Plus 1 equals 0. It does. You always, always, always have to check these solutions because not all of them are valid solutions. Last example, page 322. Square root of, instead of s, I'm going to use the variable x. Square root of x minus 8 plus square root of x equals 2. I'm going to isolate the larger of the two radicals by subtracting square root of x on both sides. So I'm left with square root of x minus 8 is 2 minus square root of x. Once I've isolated the larger of the two, I then square both sides. On the left-hand side, I'm just left with what's under the variable. It's x minus 8. On the right-hand side, it's that binomial times itself. And I will FOIL it. All right, 2 times 2 is 4. 2 times negative square root of x is 2, minus 2 square root of x, minus another 2 square root of x. Negative times negative is a positive. Square root of x times square root of x is x. All right, so I'm going to move the 4 and the x to the other side. Combine my like terms. I'll subtract 4. I'll subtract x. The x's on both sides cancel out. I'm left with negative 12 equals negative 4 square root of x. These are like radicals. I divide both sides by negative 4. We're left with the square root of x. The value is 3. I square both sides. The value of x is 9. In both of them, x is 9. Interesting. All right, so we'll plug it back in because it has to be checked. This is 1 plus 3 does not equal 2. It is not a solution. It's not a solution. So there are no solutions to this equation. No solutions. What does that mean? It means for that equation, it does not cross the x-axis. There are no solutions for x.